So let's see if I can convince Preview to let me view both at once. Excellent, less excellent, more excellent. Let's go back to drawing. And one more time, because I had already matched the graphs to the equations, I said that A, and now my stylus is not responding at all, so that's kind of fun. Come on now. There we go. I said that A should be 3, that B should be 2, C should be 1, D should be 6, E should be 5, F should be 8, G should be 4, and H should be 7. Okay, now I'm ready to start looking at my contours. So I said for A that matches graph 3, and when I think about taking slices in Z, I expect to get sometimes circles, but also sometimes I'm going to get these kind of lines going on, especially as I sort of weave between sort of the hills. So first of all, there's only one of these that has multiple circles going on, and that's number 1. Plus, I see those lines happening as I weave between the hills. Plus, you know, it also, I'm pretty happy about the fact that they're not exactly circles, because I didn't exactly get the equation of circles when I was setting Z equal to a constant before. There are these weird sort of square shapes that I am very ready to believe that that's what happens when you take arc cosine of sine or something like that. So I'm going to say this is 3, and it's also contour plot 1. Let's look at B. B is Z equals XY and is equal to contour plot number 2. Now, I'm thinking if I take slices in Z, I'm kind of expecting to get hyperbolas. Like if I fix a value of Z and I slice along, it looks like I get equal along here and then sort of catty corner along here. So I'm looking for hyperbolas. A few of these have hyperbolas. Let me see if I can move my video somewhere less obtrusive. That works. And now it won't let me go back to drawing. Thank you. So I see hyperbolas happening in 2 and in 5 and in 7. But one thing that's happening, I see happening in 2, in graph 2, is I expect to see this nice sort of T shape as opposed to an X shape, if that makes sense. I expect that when X is equal to 0 or Y equals 0, then Z equals 0. So that's telling me I should pick 2, because that's really not happening in 5. I'm not getting this shape going on as a contour, and I'm also not really getting it in 7. I'm kind of hinting to it, but I'm not hitting on it. Plus, what I like about 2 versus 7, I've definitely ruled out 5 as because it doesn't have this plus shaped contour. What I like about 2 better than 7 is that 2 is more, the contours are kind of nicely spaced. It seems like I'm changing with time in a pretty mellow direction, whereas 7, the fact that these are getting closer and closer the closer I get to 0 tells me I should be bunching. The function should be changing quickly near X equals 0 or Y equals 0, and that's not really the case with my graph 2. So I'm going to say that graph 2 should then match function 2, or rather contour plot 2. All right, let's see if we can erase some of these scribbles. And let's look at C, which matches graph 1. And in this case, I'm expecting when I cut across in Z to get straight lines. So looking at these, who has straight lines? That's either 3 or 4 or 6. But when I'm looking at these straight lines, first of all, I expect them to be parallel or perpendicular to my axes, depending on if it's an X or Y. I don't expect a diagonal. So I'm going to rule out both 4 and 6 and lock in on 3. And the thing that really seals the deal for me, that convinces me I must be doing this right, is the fact that they kind of bunch close to 0, where I have this sharp curve, and then they spread out as I get farther away from 0. And as x gets bigger, indeed, 1 over 1 plus x squared is just getting closer and closer to 0. And so it makes sense the graph flattens out over time. And this is what it looks like in the contour plot, where it flattens out over time. So I'm going to say C goes with graph 1 and contour plot 3. And I'm wondering now if I remembered to shuffle these before I put them in their contour plots, but we'll see. Let's look at D, which is cosine x plus y. So cosine x plus y, we said, went with graph 6, where again, when I take cuts in Z, I expect to get these nice straight lines. This time, yes, on the diagonal, not horizontal or vertical. So that gives me my choice of 4 and 6. And of the two of those, I'm leaning more towards 4 than 6, and I'll tell you why. When I'm looking at 4, I see that I kind of, on top, I have these sort of mountains and I get almost to a plateau. And the same that down at the bottom, I have these valleys that sort of even out, but then in between, I change quickly. So it's kind of like when you're at the top of a roller coaster and you're waiting so long and then you shoot down. And then you slowly build back up and shoot up. And because of that, I expect my contours to bunch tightly in between and then space out at the top and bottom. Now 6, everything looks pretty evenly spaced, but 4 seems to reflect the fact that I change quickly and then I stay the same for a while. I change quickly and then I stay approximately the same for a while. I change very quickly and then I stay approximately the same for a while. So for that reason, I'm going to end up saying that this should be 4. Another way I could think of it is that since I have cosine of x plus y, I expect to get I expect my contours to correspond with set values of x plus y, that if z is equal to a constant, then the arc cosine of z is a constant, and x plus y equals a constant, say c, gives me the line y equals negative x plus c. And even though I don't know which axis is which, for here, I'm probably going to assume this is x and this is y, in which case y equals negative x plus c is going to give me lines that tilt this way as opposed to this way. So I'm going to say that this one should be 4. Let's erase my nonsense. And look at the next one, which is E. E is y squared minus x squared, and that corresponds to graph V. And so I want to think about taking slices in Z. And again, I'm thinking that when I take slices in Z, I'm going to get hyperbolas back again. It's not too clear what these look like. They're going to kind of look like this in one direction and kind of look like that in the other. So I'm expecting to get these hyperbolas. I think this is an accurate picture. But in particular, I already used this one. The other ones with hyperbolas are here and here. I again don't see anything really crazy going on when I take x equals 0 or y equals 0, so it's probably not this one, and I already used this one, so I could say by process of elimination it should be this one. I can also look at, okay, one of the contours should be when z is equal to 0, and if 0 is equal to y squared minus x squared, that gives me y squared equals x squared, and that gives me y equals plus or minus x, which is itself an x shape. And I see that happening here, and I don't see it happening for any of my other contours. So I feel pretty good about calling this one 5. Let's erase again. And look at the next one, that z is the absolute value of x minus y, which corresponded to graph 8. And this one, I expect when I cut a certain z value, I get these nice diagonal lines. Again, I'm running out of options at this point. I think I've used up all my straight line ones except for 6. Now, why does 6 make sense here? Well, not only do I have diagonals, I have also got the correct shape for my diagonals. That if I set z equal to a constant equals absolute value of x minus y, then that means x minus y equals c, or x minus y equals minus c, but both of those are going to go to y equals x plus or minus a constant. So I get these sort of x equals y plus or minus a constant curves. Also, these are very nicely evenly spaced, which makes sense because z is basically linear in x and y. If it weren't for this absolute value, I would get a plane where I would just get perfectly evenly spaced values. It's definitely not bunching like this one or this one. So just this nice even spacing is confirming to me that this should be choice 6. Let's look at G. G is log of x squared y squared, which I said corresponds to this graph, and this graph 4. And when I try and take slices in Z, I get not really a true hyperbola shape because I'm getting sort of a 4-sided hyperbola. But more significantly, because I've got this sort of problem where x and y equals 0, the function changes very, very quickly near there. And so both of those are indicative of 7. Not only does it give me that quasi-hyperbola shape, I can see that the contours are bunching really closely together when I'm close to the axes, and that matches my graph. So I'm going to say that graph 4 matches contour plot 7. Yeah, looking at this, I'm starting to think that I either did not shuffle the contours from the functions, or I thought I was being clever to have the contours match the functions, but the graphs be something else. And once again, I can either say by process of elimination that H, which goes with graph 7, should match contour 8. Or I can look at the fact that, as I've said a couple times, when I take cross sections in Z, I get circles. And so when I look at my contour plot, I should see circles. So this one should be number 8. So these are my final answers. I hope that explains to you reasonably well how I found them, but if you have questions, you can absolutely ask me during office hours. You can shoot me an email, or you can ask during class on Thursday during the merit hour after we take the quiz during the first hour. So hope this helps, and if I can figure out how to end the Zoom meeting, I will see you later.